Let us take one more example. It says find the Kp for the reaction, which is given here, if 40% of the H2 has reacted at equilibrium at 2 atmospheric pressure. So we are only given the pressure in which the reaction is taking place, which is 2 atmosphere, and it says 40% of hydrogen has reacted by the time it reaches at equilibrium, and the reaction is when hydrogen reacts with iodine, it forms Hi. So what we know is we have to find out Kp. Remember, it's not Kc. So here the things are different. We will be taking the amount of Hi, iodine and hydrogen in terms of their partial pressures. But first find out initial moles. If the initial moles of the two gases taken are 1 and 1, of course the Hi is 0. And we know that the alpha here is 40%, which will be 0.4 moles when we are taking 1 mole of hydrogen. So equilibrium moles will be 1 minus 0.4, because 0.4 has reacted. So how much of hydrogen is left? It is 1 minus 0.4. Similarly, 1 mole of this reacts with 1 mole of this. So how much moles of iodine is left is 1 minus 0.4. But we know 1 mole of hydrogen forms 2 moles of Hi. So if 0.4 moles has reacted, double of this, that means 0.8 moles of this will be formed. If we could not understand this, we can write the same thing in this form also. It will be 1 minus alpha, 1 minus alpha and 2 alpha. Because what is alpha is the how much of the amount of the moles of the hydrogen has reacted. So what is left is 1 minus alpha. Again, how much of moles of the iodine has reacted? It will be same, because 1 mole of hydrogen reacts with 1 mole of iodine. So how much moles of iodine left is 1 minus alpha. And since 1 mole of hydrogen forms 2 moles of Hi, it will be double. So if alpha has reacted, twice of alpha is formed. Since we know the alpha here is 0.4, it will be 1 minus 0.4, 1 minus 0.4, it is twice of 0.4, so it will be 0.8, it will be 0.6, it will also be 0.6. So these are the moles of these three substances involved. How can we write down the Kp? See, Kp expression says partial pressure of Hi, square of this, partial pressure of hydrogen and partial pressure of iodine, because we have to take the partial pressures. Now, how to find out the partial pressure? We know this. Partial pressure of any substance is equal to mole fraction of that substance into P total. I am repeating again. Partial pressure of any gas is equal to the product of mole fraction of that gas into the total pressure. PD means this is your total pressure, which here is 2 atm. Whereas how to find out mole fraction? This mole fraction of Hi will be equal to the number of moles of Hi upon number of moles of Hi plus number of moles of hydrogen plus number of moles of iodine. That means total moles. So let us find out first, therefore, what is the total number of moles in this is? Total moles are 0.6 of hydrogen plus 0.6 of iodine plus 0.8 of Hi. So it will be 2 moles. Total moles. Therefore, mole fraction of Hi will be how much? Number of moles of Hi upon total moles. How much is the number of moles of Hi? It's 0.8 by 2. Similarly, the mole fraction of hydrogen will be 0.6 by 2, and the mole fraction of iodine will be 0.6 by 2. And total pressure we know is already given, which is 2 atm. So now let us now put these values in this expression. What we get is, it will be 0.8 upon 2 into P total is 2, the square of the whole, 0.6 upon 2, these are the number of moles of the hydrogen, upon total number of moles into total pressure 2, upon 0.6 number of moles of iodine upon 2 the total number of moles into 2, which is your total pressure. So this square of 2, this gets cancelled. The square of this 2 will also gets cancelled. So what we get here is 0.8 into 0.8 upon 0.6 into 0.6. When we solve this, it comes out to be 1.77. So this is how we know, you must know how to find out Kp, the equilibrium constant in terms of partial pressure. When it is written Kp, remember all the coefficients, all these the reactants and the products are to be taken in terms of their partial pressures, and partial pressures are always determined by using the formula that partial pressure of any gas is equal to the product of its mole fraction and total pressure. So these are their mole fractions into total pressure. Put these values in the expression, just find out the answer. This is how we can find out the values of Kp.